VLSM, not a word you say every day. And actually, it's not a word that you ever say. People will either say VLSM or the ultimate subnetting form, variable length subnet masking. This is going to be probably the final subnetting topic that we discuss. And that's because we've really exhausted it. We've seen how we can subnet based on network requirements, host requirements, how to go backwards or reverse engineering a subnet problem. And now we're into the final form, which is variable length subnet masking. And the good news is this. There's nothing really new here. Variable length subnet masking is just taking multiple subnet problems and kind of stacking them into one. It's kind of like when you learn math and like, okay, here's how you do addition, subtraction, and then they're like, oh, and by the way, a train is leaving Vegas doing 100 miles an hour in a region. It's kind of like, okay, so I got to take multiple skills and kind of put them together to solve that, right? That's variable length subnet masking. So here's where this fits in. Let me flip it over here. This is I'm planning on doing two. I'm going to do one in this video because you're just getting used to what VLSM is. It's going to be a simple example of VLSM, and then in the next video, I'm going all out. Right? So this is the topology I've used in a number of skills up to this point. And up till now in Arizona, Nevada, and Florida, I've been using just temporary subnets. I've been saying, let's just call that 192.168.1.0 and 2. Just because I needed some addresses, but we didn't have the conversation about subnetting yet. So here's how VLSM would come about. The problem says, or the network situation says, or whatever is saying, Arizona's got 100 devices, right? Okay, Florida and Nevada, 20 devices apiece. And the WAN, which is this network right here, needs a subnet that can expand up to 10 devices. Oh, by the way, forgot to tell you, you can only use 192.168.10.0 because the architect has only given you a single Class C network for this entire thing. Huh, okay. So without VLSM, what would you do? I mean, I'd look at it, I'd go, okay, well, I guess I would figure it out based on 100 devices, right? Because that's the biggest subnet, and I would get that, and I'd have my subnet mask. But the problem is, you'll be able to do this too. You'll do subnetting in your head. If I look and I go, okay, 100 devices, and your increment to get something like that is going to be 128, right? So you can't really chop that up into multiple 128s, right? You'd get two. You'd get subnet 1, which is 0 through 127, and subnet 2, which is 128 through 255. That would get Arizona and maybe Florida, but now you've got Nevada and the WAN. You're out, right? So do you see the need? This is called efficient subnetting, variable length. You're changing the length of the subnet mask whenever and wherever you want. The whole secret sauce of variable length subnet masking is that you should begin with the largest subnet first. And I'll tell you why in just a little bit. So it's just multiple subnet problems in one. So let's just start off. And we've got Arizona has 100 devices, right? So, okay, we'll do a little miniature version of our three-step process. 100 in binary is, and I'll just throw it up here, 128, 64, 32, 16, 8, 4, 2, 1, right? If we're converting that to a binary number, we'd go, boom, right there. So we know immediately it takes 7 bits to get the number 100, right? So part 2, our original subnet mask that I accidentally erased is 192.168. Actually, I'm gonna write this off to the side so I save my room. Down here, 192.168.10.0. That was what we were given, right? And it was /24. So /24 in binary is 24 ones. So that's 24 ones. Dot 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let me ask you. In this situation, are we creating more networks or saving the host? I'm throwing enthusiasm at you to kind of get you in the right direction. We're saving the host, right? Because it said Arizona has 100 devices. It didn't say Arizona needs 100 networks. It's saying I can't address Arizona if I have any less than 100 IP addresses. So I'm saving right here 1, 2, 3, 4, 5, 6, 7 zeros. Foop. That guy can flip over to the network side because we're doing subnetting, right? So we go to a /25, or in decimal, that'd be 255.255.255.128, right? Good. We're on to step 3. What's our increment? Lowest network bit back in decimal form is 128. So I'm going to go with a different color here. 192.168.10.0 is where we start. Then we go to 192.168.10.128 because that's our increment, right? And now I could keep going, but stop. How many networks of 100 devices do I need? Think about that. Just one, right? It's just Arizona. 100 devices. That's it. So I go, okay, well, I'll fill in that end range that goes through 192.168.10.127, and now I've got Arizona. So Arizona, check. You've got your subnet. It's that guy. Put a little /25 on the end of that so I know what that subnet mask is. Good. And now the joy, it's pure ecstasy in VLSM is you get to do it all over again. Now we move to the next biggest subnets, which is Florida, Nevada. They have 20 devices each. So let's just hop over here. Let me get my red pen back. Okay. And I'll say, okay, well, 25. I'm back to step one. 20, oh, not 25, 20. There we go. Is going to be, I'm like up here, boom, right there. That's where my first one goes. Get rid of that one. So it takes 5 bits to get the number 20, right? Cool. So step 2 is now I go back to my original subnet mask. It's as if Arizona never happened. It didn't happen, at least not yet. So our original subnet mask is a /24, which equals that 24 ones, and then 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, so am I creating more networks or saving the host? You got it. Saving the host because Florida, Nevada, 20 devices. They can't address their network if they have any less than that. So we're saving zeros going right to left. 1, 2, 3, 4, 5. Because we can't get the number 20 with any less than 5 bits. The rest of these, shoop, 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 over to the network side. Okay, and you ready? Ready for the complexity of VLSM? Because it's all right here. This is it. I go, okay, well, let's go 192.168.10.0, right? And I go, okay, well, our increment is going to be 32, 128, 64, 32, right? Good with that, right? So it means 0, 32, okay, let's have a little discussion here for a second. Can I use any of these? Why not? What's the problem with that? Well, you can't because it's an overlap with Arizona. Oh, okay. So the secret of VLSM is I just pick up wherever Arizona left off. This is the beauty of the powers of 2, is when you start with the largest subnet, like 128 or 64, whatever the case is, you're like, if you count to 256 by 2s, you're going to hit 128, right? If you count to, 256 by 16, you're going to hit 128. They're always going to hit these increments. So it's easy for me. Now you could, if it threw you off, you could go, okay, 0, 32, I can't use that. I can't use that. I can't use that. I can't. And you would eventually get down to 128, but I would just say, okay, well, let's save a little time, as much as I like counting by 32. Let's just start from 128 because that's where I left off right here. And then go, let's see, 128 plus 32, that'd be 160, right? Plus 32, that'd be 192, right? Let me stop. How many networks of 20 did I need again? Yeah, right? 2. So I can stop right there. 159, 191, and I got it. That's it. Oh, I forgot to change pen colors, but that's okay. I'll write them up here. Nevada, 192.168.10.128 through 159 is its network range. I'll do a slash. Oh, I forgot. /20, 24, 20, 27, right? 3 more bits that we added on there. So it's /27. And down here in Florida, hey, you get 192.168.10. Are you getting this? Come on. It feels good, doesn't it? You're like, oh, I totally get it. I can feel it, right? And if not, that's okay. You can watch it again. You'll get it. So, I mean, this is real. This is real. I can go in here and I can say, this is my default gateway. It will be 161. This is a computer on the network, and it will be 162, and it will use 161 as its default. I mean, it's a real network. Oh, I forgot. /27, right? Because it's that subnet mask that tells them what's there. Good. Are we done? Are we done? No, there's one more. I know, you're like, oh, we're done. No, we're not done. We've got the last one, 10 devices. By the way, do you see why I started with the biggest subnet first? Think about what would have happened if I would have started with 10 devices, right? You get this little subnet at the very beginning. You're like, oh, I've got, let's just say 1 through 15 or whatever it comes out to, right? And all of a sudden we try do the biggest one next, and we're like, oh, man, I can't use any of that range because it overlaps with that little subnet, right? It makes sense, right? So that's why we stack it up with the biggest subnet first. Okay, so let's do this last one. Yeah, I'm going back to I'm going black. 1. How many bits does it take to get the number 10? So 10, we'll put our first 1 right there, so we know it takes 4 bits, right? Original subnet mask is a /24. Don't skip this step. I know you'll want to go fast, but don't do it. You don't want to mess up. 1, 2, 3, 4, 5, 6, 7, 8. It's as if I had never done subnetting. Am I creating more networks or saving the hosts? I'm saving them. So right to left, 1, 2, 3, 4. 1, 2, 3, 4. /28 is our brand new subnet. Then we go down. Oh, forgot. Increment is going to be 128, 64, 32, 16, right? And now I'm remembering to change my pen color. So step 3, 192.168.10. So again, I could start from 0, but I know I can't use any of those. I know I can't use any of those. I know I can't use any of those. So what's a man to do? You pick up right where it left off. Because again, if you count by 16s, you'll eventually get to 192. So I'll put 192 plus 16 will be, that'd be 8, right? 8. Oh, wait. Yeah. Okay. Carry the 1. There'd be 208. It's not a normal value I see every day, so it took me a sec. So 192.168.10.192 through 207 will be it. That's our network range. /28 is the subnet mask, so that's where I would go to the Metro E Cloud and say, you, my friend, get 192.168.10.192 through, get that guy out of there, 207. 207. So again, real thing. You could say, okay, you're .193, you're .1, and this is, by the way, /28. Oh, that's a terrible color. So this would be 194, right? It's all in the same network. Is this helping? Oh, that's duplicate. 195. That's VLSM. So VLSM is really just stacking subnet problems on top of each other. Does that make sense? That's all it is. Now, something that I've had asked a lot when I show an example like this, somebody's like, okay, well, what happens when Arizona grows to 200 devices? What do you do then? Well, then it's you blew it up, and that's why these kind of things right here work on paper, but you would not do well, I'm not going to say you would not, but you would not do a subnetting scheme this tight in the real world because. Nevada, that's even a more likely one to expand because it's only 20, right? Office grows, you just blew up the whole subnetting scheme. So you would, again, use the skill of VLSM in a real world like, okay, let's think about growth. Like Arizona might need a second subnet or a third subnet. Where this skill works really well, where this skill works really well is for the ISPs. Think about that. You've got the internet carrier who buys these giant blocks of IP addresses that are public and very costly. Let's just say 200.1.1.0, /24. And they have to give them to all of their different clients of the world. That's where they use VLSM all the time. And they're chopping that things up all over the place. And have you ever I don't know if this just happens to me. It happens all the time for networks that I've managed. A lot of the lower end carriers, I'm talking like cable modems, DSL, that kind of thing, they'll send you a notification. They're like, hey, we need our addresses back. We're going to be doing and what that means is essentially they blew up their subnet. They had a customer request or purchase a big block of addresses, and they're like, oh, let's just redo all of that. And so that's where VLSM comes in all the time. And that's it. That is the ultimate subnetting form. Variable length subnet masking. I hope this has been informative for you, and I'd like to thank you for viewing.